Hello everyone and welcome to DevSummit 2021. When ARM first started 3 decades ago, there were just 12 engineers in a converted turkey barn just outside of Cambridge. Although the company was set up to design microprocessors, from the start our founders fully understood the importance of software. These were the early days of RISC, and the mantra was that a RISC CPU was only as good as its compiler. And so we had a small team working closely with a group from the University of Cambridge, developing software tools to ensure that the hardware we created could be fully utilized by code. It's 30 years later, and the code running on ARM processors has got a lot more sophisticated. But the need to ensure that the hardware and software are co-developed is as critical as it has ever been. This is why coming together at DevSummit is so important. It's about the convergence of the software and hardware developer ecosystems. And while we are virtual for the second year in a row now due to the pandemic, it won't stop us from nurturing the powerful collaboration that enables us to co-develop the technologies that unlock our shared success wherever development happens. My interest in computing started when I was about 14. My best friend told me about this shop in our hometown that had a Sinclair ZX81 on display that you could actually go and program yourself. I'd never touched a computer before, and we would go and write the most simple programs, learning about concepts like variables and loops, really simple stuff. After school, we would go play on the machine until they threw us out of the shop. It was expensive. At £70, we weren't about to buy one. Now, the ZX81 was primitive by today's standards. It had a 3 MHz 8-bit microprocessor and a whole 1 kilobyte of memory. But at that time, to me, it seemed like a box of magic. Now, sadly, its creator, Sir Clive Sinclair, passed away in September, and I want to take a moment to thank him for inspiring me and a whole load of other ARM people who are roughly my age, with a desire to know more about how computers worked and how to code. I was interested in the hardware, and I would try and build basic circuits, following the designs I found in magazines. Usually, if I'm honest, they didn't work, but I learned along the way. My interest in low power was born out of necessity. I didn't have a power supply, so anything I built needed to run off a battery. There was another shop in my hometown where I would buy individual transistors, resistors, and capacitors, and then try to build things that could be powered off a pair of AA cells. Just making some LEDs flash was success. When I finally got my own computer, a BBC Micro, I was able to expand my programming capabilities and also hook the computer up to external circuits via its expansion port. It was a great platform on which to experiment with the interaction of hardware and software. Now I could make the LEDs flash with a program, and I thought that was really cool. But I wanted to learn more, and I knew I'd only get so far reading magazines and experimenting at home, and so having found my passion, I went to university to get a degree in electronic engineering. That eventually brought me to ARM and that barn in the Cambridgeshire countryside. Joining ARM fueled my curiosity further and allowed me to channel it into the technological movement all of us here are now part of. One of the most exciting projects I worked on had me leading the team that developed the ARM7 TDMI CPU. Many of you know it as the processor that would unshackle compute from desktops and mainframes, but it also served a very important purpose for our own developer ecosystem. It was one of the first embedded processors, but along with its benefits came a new challenge. How could you debug and test code running on a processor that you can't access because it sits inside a more complex system on chip? That led us to create an embedded in-circuit emulation solution, which allowed instructions and data to be scanned in and out of the CPU via JTAG scan chains. With our investment in the debug tools to utilize this hardware, we enabled software engineers to perform actions that today we take for granted. Actions such as single-stepping through code, setting breakpoints to stop the processor when you hit a problem area, or viewing the CPU registers or the contents of memory. These techniques and workflows have become standard practice today, but they were born out of a necessity brought about by the advancement in semiconductor technology that enabled a processor to become the building block of a bigger chip. Hardware technology improves quickly, and with it comes new opportunities and challenges. requiring increasingly complex languages, libraries, and frameworks. Wrapping your head around the rapid pace of innovation can be daunting, and that's before you lay down the first line of code that will form the foundation of your next great idea. Whether you've been a developer for 30 years or 30 days, no doubt you've encountered obstacles that stand in the way of your creativity. We think about this every day. At our core, we are an engineering-focused organization. We fully understand that all this technology we're building, all of these advancements, are for nothing if we don't provide you with the tools and resources that empower you to make the use of them. For the past 3 decades, we've invested in innovations that make it easier for you to write fast and run fast. So let's talk now about what the not-too-distant future will look like, as designed by you in the ARM developer ecosystem and enabled by the technologies we build to invest in our shared success. Earlier this year, we introduced ARM v9. We engineered it to be the foundation of the next decade of compute. It delivers the power of specialized processing with the design freedom, accessibility, and economies of scale that come from the world's most pervasive computing platform. It's built to address the needs of today, but with the flexibility and foresight required to be ready for the challenges ahead. Our industry is changing and innovating more rapidly than ever before. We have more devices, more people and data, driving faster and faster cycles of growth. This means that computing, security, and sustainability challenges require fundamentally different and increasingly complex solutions. In that context, you're expected to innovate faster while mastering an ever-increasing complexity. Designing world-beating technology is hard and involves countless trade-offs between features, performance, power, time to market, and many other factors. Finding the right balance is difficult, and that's why we designed ARM v9 to give you the foundation to power the full spectrum of compute, from supercomputers all the way down to the smallest microsensor, easily, flexibly, securely, and efficiently. We're providing the foundational building blocks of computing, enabling you to innovate on top of what we do, so that the end solution is tailored for the application you are targeting. This is what we mean by specialized processing, a flexible hardware platform built on standards that make it easy for software to be developed and reused, saving you valuable time and resources. Creating a set of performant, standardized solutions reduces development time by solving hard problems around aspects such as system simulation, modeling, and emulation. This allows for increased differentiation. The time you save on building out the foundation of your technology can be focused on differentiated R&D. Even as we focus on helping you innovate faster, we know that having more devices and more technology comes with more security risks. You, your customers, and the customers they serve need to feel confident that their information will be protected. As a result, there is an onus on all of us to work together to enhance the security of electronic systems so that they can be trusted by consumers. Hardly a day goes by without news of another security breach, and since the start of the pandemic, ransomware attacks have been on the rise. Attacks are now so pervasive that the US Justice Department has created a ransomware task force to investigate extortion-related cyber attacks. That's because the ambition of hackers has increased. No longer content to steal identities or credit card numbers, they are increasingly turning their attention towards government agencies and critical national infrastructure. In September, New Zealand had a number of its financial institutions and its National Postal Service attacked, forcing its systems offline. CyberMDX is a leading healthcare cybersecurity firm, and according to a report they recently published, nearly half of all US hospitals have had to disconnect their networks at some point in the past 6 months due to escalating attacks. In some cases, hospitals have had to cancel surgeries and patients have suffered. Clearly, these aren't victimless crimes. Many cities around the world are currently seeing record highs in the number of ICU patients due to COVID. Just imagine the feeling of helplessness if someone in your family was critically ill but couldn't be admitted to hospital due to a ransomware attack. We have to do something about this. Addressing this growing problem requires a fundamental rethink of how software is written and how data is stored, so that we can limit a hacker's ability to disrupt business and everyday life. It requires ecosystem changes, and that's not something that a single developer or company can solve on their own. Managing these sophisticated security challenges requires a broad collaboration, since we share a responsibility to stay ahead of increasing cybersecurity threats. For many years, we've been pushing for higher security standards across the industry, and we continue to do so with the recent release of our latest security manifesto. It discusses how we all must continue to work together to create foundational technologies and best practices that help us mitigate the risk of cyber attacks. One industry-wide solution to this is called confidential compute, and it's a new approach that goes beyond just encrypting stored data. It shields both data and code from unauthorized access or modification while it's at rest and while it's in use. Confidential compute is built into Armv9, engineered with the knowledge that we are all less secure when any part of our technological world has a vulnerability. Part of what is driving the increase in cyber attacks and ransomware is the pervasiveness of technology itself. But this proliferation of technology isn't only significant for its security implications. It has serious ramifications for our planet. This year, we are already seeing record high temperatures across Europe, Asia, and the United States. In California, where I live, a combination of abnormally high temperatures and drought conditions have created longer and more devastating wildfire seasons. To put this in context, this year so far, over 7,000 fires have burned roughly 2 million acres of woodland. But all over the world, floods, droughts, high winds, and extremes of temperature are impacting daily life and day-to-day business. If we don't act now, it will have catastrophic consequences on our ability to sustain life on the planet. The ways that technology can be used to solve climate challenges are going to be front and center at this year's UN Climate Change Conference, and we want everybody in the Arm ecosystem to be part of the solution. At Arm, we are committed to achieving carbon neutrality by 2023 and to reducing what we use to minimize our environmental footprint. Low-power compute has long been part of our DNA, and as the use cases for compute grow every day, Arm remains committed to driving further efficiencies so that together we can decarbonize compute. We can't honestly say that we're building for the future world if we're not making our own products and our internal business processes more energy efficient and sustainable. We're not alone in this mission. One of our partners, Cloudflare, is leveraging Arm technology to help it achieve its carbon neutrality goals. They understand the impact of how the hardware and software developer ecosystems can converge to tackle this important challenge.
At Cloudflare, we're committed not only to removing all historical carbon footprint from across our network by 2025, but also helping our customers reduce their carbon footprint by using Cloudflare's products. Over 25 million internet properties run on Cloudflare's global network. It spans more than 250 cities across more than 100 countries. Our mission is to help build a better internet, one that's safe, fast, and reliable, but also one that consumes less energy. The only way we can both grow our business and consume less energy is by adopting technologies that deliver best-in-class performance and power efficiency, with the ultimate performance per watt, like we get from Arm Neoverse-based servers. Compared with our 10th generation servers that used a traditional CPU architecture, our new Arm-based servers process an incredible 57% more internet requests for every watt. Arm is the future. We think there's a real competitive advantage for any developer that adopts Arm earlier. We've had a great experience and we're excited about the future, and the next several years should be really promising.
Thanks, Nitin. We've built our heavily customizable IP on a highly energy-efficient platform designed to ensure that with the rapid growth of compute that we anticipate, the impact on the planet is minimized. And this is significant because as we enter the next decade of computing, technologies such as IoT, 5G, and AI are reaching new levels of maturity that will result in billions more devices in the world. Pervasive computing will reach a scale we have never seen before. And as the nature of computing evolves, so too does the nature of workloads. Let's start with IoT. Today, there are more than 10 billion IoT devices in the world, making a difference to our lives, often in a seemingly invisible way. One that comes to mind is the RAM1, a smart electric grid monitoring system. It uses an embedded machine learning algorithm running on an ARM Cortex-M processor to monitor power lines for fire threats in real time. When it senses that a power line has been physically damaged, it automatically cuts power to it, preventing sparks that could lead to wildfires. And it's energy efficient too, designed to last for 20 years on a single battery charge. The use cases for IoT are seemingly limitless, enabling everything from smart homes to smart cities. One great example of smart infrastructure is the Flowwell by transportation firm Coles. It's a smart LED road surface driven by an AI-powered dynamic signal controller called Starling Control. It reacts in real time to pedestrians, to cyclists and vehicles to create new traffic patterns, helping to make cities safer. It will be deployed across several locations in France by the end of 2021, and with the promise of more to come in the future. Applications like these, or your next great idea, require innovation at the intersection of hardware and software, viewing these two domains as one in a system-level approach at all stages of development. We've started our work with projects such as Cassini, and this week we've announced what we call ARM Total Solutions for IoT, our holistic approach that brings together hardware and software for IoT technology. It's built on an extension of our software strategy to broadly enable modern, cloud-native inspired application development for IoT. Similar to how a platform approach opened up mobile to an ecosystem of developers, we will work together to provide the foundation for a new IoT economy. Mohammed will be exploring more of this in his keynote coming up next. I encourage you to stay tuned for that. Another area where we anticipate significant growth and opportunities is 5G. 5G handset adoption has ramped much faster than previous generations, with more than 80 million new subscriptions in the second quarter of 2021. This is just the beginning, though. 5G is about much more than the next generation of handsets. In the coming years, more infrastructure will be deployed to enable 5G's full potential, the majority of which will be powered by ARM-based chips. When this infrastructure transformation is complete, it will be paired with edge computing to deliver the reliable, high-speed, low-latency connectivity needed to power data-hungry applications that will enable the creation of automated factories, connected cars, and augmented reality experiences. That infrastructure will open up a new world of possibilities, and to help jumpstart application development, I'm pleased to announce today the creation of the ARM 5G Solutions Lab in collaboration with our partner, Tech Mahindra. The 5G Lab will focus on accelerating solutions enablement, utilizing key 5G infrastructure, such as small cells, distributed RAN, and Cloud RAN. The lab will provide secure access to ARM-based hardware and software, as well as provide support and expertise from the ARM ecosystem. The intention here is to make it easier for the hardware and software solution developers to come together, to collaborate and to innovate, and to truly realize the potential of 5G. For the ARM ecosystem, we envisage this lab to demonstrate and accelerate sustainable 5G solutions that underpin the ARM architecture's inherent benefits of performance, power, and cost. Later this week, we have a session called the 5G Ecosystem Campfire, where you can learn more about the lab. Check it out and see how you can get involved. Everything we've discussed so far, whether it's the efficiency of specialized processing, the security of confidential compute, or the sustainability of our low-power technology, all lays the foundation for our investment in the most important technology of the next 50 years, AI. Whether being used by automakers to develop self-driving cars or by medical researchers to accelerate the discovery of life-saving medicine, AI is set to become the most impactful technology of our lifetime. AI is entering a new stage of development, but it's still early days. Our efforts to enable AI started many years ago, and we anticipate that this technology will enhance the entire spectrum of computing. Each month, ARM licensees ship about 1 billion M-class devices, and we constantly see new ways in which developers are utilizing these small but powerful processors to create AI-based solutions. We created ARM Ethos processors to further enhance AI performance, and the first Ethos-enabled devices are starting to ship. I'm looking forward to seeing what you do with them. Looking to the next decade of compute, ARMv9 will continue to accelerate these advances for next-generation devices, meeting the ever-increasing demands of AI processing. But we see an even greater opportunity to turbocharge our capabilities. I'm, of course, talking about the future of ARM with NVIDIA. ARM's compute platform, combined with the strength of this developer ecosystem and NVIDIA's deep expertise in AI, will result in AI becoming as pervasive as compute is today. I know I said it's early days with AI, but frankly, I'm amazed by what developers in this ecosystem are already doing with the technology. There are some incredible examples out there. But harnessing AI is complicated, and I see some similarities between where AI is today and where computing was 30 years ago. Back then, computers transformed from grey boxes sitting on desks to being deeply embedded within complex chips. With that came new challenges for developers. At ARM, we worked with you to solve these issues so that you could achieve better performance and better power efficiency. All along the way, we created systems, frameworks, and tools, such as embedded ICE, which enhance your productivity. It's the same with AI. AI is moving from the cloud and from supercomputers down to embedded systems, and with that transition comes another set of challenges that we must overcome. We need to accelerate the usage of AI-based software into embedded systems to enhance your productivity while delivering performance and without sacrificing power. That's what we'll focus on in the future, delivering the IP, the tools, and the infrastructure that quickly enable you to build AI systems and shorten development cycles. It's an exciting future, and I can't wait to get started. It's almost time for me to hand things over to the rest of the team. But before I leave, I want to express my sincerest gratitude on behalf of all of us here at ARM. Everything we do means nothing if you can't bring the technology to life. Your creativity inspires us, and your feedback drives us. You are integral to the work we do every day. When I programmed that ZX81 roughly 40 years ago, it ignited a curiosity that eventually led me here to be talking to you all today. At ARM, we envisage a future designed by millions of minds based on science and engineering, rooted in building a more secure and sustainable world for generations to come. Our purpose is to unlock the power of technology and to spark the world's potential by working with brilliant people like you. Alongside you in this developer ecosystem, we will work hard to deliver the technologies and the tools you need to harness during the next decade of compute, so that together we can be prepared to address the opportunities we have yet to discover. I hope that you and your families are staying safe during this pandemic, and that next year we can all be together in person. Thank you.